At full employment output, real GDP equals potential GDP, and the unemployment rate is equal to its natural rate. Y, real GDP, equals Y subscript FE, which is full employment output, also known as potential GDP. UC, cyclical unemployment rate, is equal to 0. Economic growth is 3 to 4%. Inflation is 2%. The unemployment rate is 5 or 6%. Potential GDP and the natural unemployment rate are determined by real factors and are independent of the price level. Changes in the quantity of money change nominal GDP and the price level, but have no effect on potential GDP. Aggregate demand is derived from Snarian aggregate expenditure, well, in this class it is, by imposing the equilibrium in the aggregate expenditure model, the equilibrium being Y equal AE, and then solving for the price level. So, aggregate demand is a relationship between the quantity of real GDP demanded and the price level when all other influences on expenditure plans remain the same. Aggregate demand and aggregate supply determine equilibrium, real GDP, and the price level. So what follows on the next slide is essentially solving this for the price level. And when you solve this equation for the price level, you get the aggregate demand equation. Okay, so Snarian aggregate demand is found by, like I said, replacing AE in the aggregate expenditure model with Y. Now, why did I do this? The equilibrium is the condition where aggregate planned expenditure equals real GDP. Suppose aggregate planned expenditure and real GDP aren't equal to each other, and the economy's in recession, and you manage an IHOP. Well, if you see more customer traffic coming into your business, you're going to notice that your inventories are falling because you have a little bit more traffic than you used to have. Maybe a week ago you only had 10 customers per half hour, and now you got 30 customers per half hour. So your pancake flour inventory is falling more than expected. So rather than letting it go empty, you call your flour supplier, and your flour supplier sends you a bunch more flour. So if customer traffic picks up in your business and you start selling more pancakes, your flour falls. So you just order more pancake flour, so you up your replenishment rate. So when you're upping your replenishment rate, that means that the flour supplier is probably sending you more flour and sending somebody else more flour. So the company that mills the flour has to buy more grain from farmers. And so when the economy starts to pick up, customer traffic at businesses picks up, it starts depleting inventories more rapidly than when the economy was in a recession. So all these businesses are upping the inventory levels, and they're buying more products from their suppliers, and their suppliers are buying more inputs to their process. So when that happens, Q's, all these quantities of inputs to production are rising. Well, that's going to push GDP up to equal aggregate planned expenditure. And then once all these businesses have their new higher replenishment rate set equal to their new higher depletion rate, all that means is the economy has achieved what we call Keynesian equilibrium, where aggregate planned expenditure equals real GDP. So what we did here is we added price level to both sides, and we subtracted 1y from both sides. Because remember, this is 1 times y, and that's why I have this written as 1y. Okay, now we're going to factor. We factor out the y, and we're left with MPC minus MPM minus 1. Marginal propensity to consume minus marginal propensity to import minus 1. The next thing I'm going to do is I'm going to factor out a negative. I'm factoring out a negative, so a positive number becomes a negative. A negative number becomes a positive. A negative number becomes a positive. Now remember in a previous lecture that marginal propensity to save is equal to 1 minus the marginal propensity to consume. So we're going to replace 1 minus the MPC with the marginal propensity to save. And since the marginal propensity to save is positive and the marginal propensity import is positive, then this equation in price level and GDP has a negative relationship. In other words, the slope is negative. Okay, so let's go to our example. Continuing with our numerical example from the previous lecture handout, the wealth was $5 trillion, future expected income was $7 trillion, price level is 8,000, the real rate of interest is 2%, taxes net of transfers were 3%, yada, yada, yada. Now, in order to form the aggregate demand curve, we have to ignore the price level, because remember, aggregate demand is a relationship between real GDP and price level, so we got to let both those be free variables. So we write out that starting aggregate demand curve or equation, and we just plug in the numbers one at a time. So we plug in $5 trillion for wealth, $7 trillion for future expected income, 2% for real rates of interest, 0.75 for the marginal propensity to consume, and remember, the marginal propensity to save is 1 minus that, $3 trillion for taxes net of transfers, $1 trillion for investment, $3.5 trillion for government spending, and $0.5 trillion for exports. And then, of course, the marginal propensity to import. We do some arithmetic, and we get the demand curve equaling 12.75 minus 0.5 times real GDP. Now, if real GDP is 0, the price level is going to be equal to what? 0 times 0.5 is 0. 0 subtracted from 12.75 is 12.75. Now remember, the price level is in thousands of dollars. So this is really 12,750. Now when real GDP is $9.5 trillion, we plug in $9.5 trillion. 9.5 times 0.5 subtracted from 12.75 is 8. Now that seems kind of odd, isn't it? Well, go back to the aggregate expenditure model from our initial numbers that look just like these. Remember when we plugged in 9.5 and we got 9.5? We plugged a GDP level into the aggregate expenditure model. We plugged in 9.5 for real GDP, and then it equaled 9.5 with all these numbers, including the price level being 8. That is not a coincidence. Okay. I want to point out that we're assuming that aggregate expenditure equals real GDP, that we're in equilibrium in the expenditure model because businesses are smart enough to match the replenishment rates with their depletion rates. Otherwise, if they're managing a restaurant like IHOP, they're going to get fired for letting the flour run out if their business starts picking up. Or they're going to get fired for letting the flour overfill. So in their own pursuit, in their self-interested managers who want to keep their jobs, and they're going to just match depletion rates with replenishment rates. So it's intuitive to think, or it's obvious to assume, that real GDP equals aggregate planned expenditure here. And we shouldn't be surprised that the price level is $8,000, right? We shouldn't be surprised if the price level is $8,000, because this is where aggregate expenditure crossed the 45-degree line when real GDP was 9.5. In that case, real GDP equals full employment output. Okay, so let's graph it. At point 1, real GDP is 0. Price level is 12,750. Plot that point. Point 2 is got GDP being 9.5 trillion, and the price level is 8,000. So the aggregate demand curve is the line that connects these 2 points. By assumption, remember, aggregate planned expenditure equals real GDP, because the aggregate demand curve assumes we're in equilibrium in that model. In the aggregate planned expenditure model, real GDP equaled 9.5 trillion when the price level was $8,000 at the aggregate planned expenditure equilibrium. So let's ask the question, what happens to government spending? What happens if government spending is increased to $4 trillion? It was 3.5. It is $4 trillion. So replace 3.5 with $4 trillion. And just like the aggregate expenditure model, the aggregate demand model shifts up by the same amount. Now remember, the aggregate planned expenditure model had a positive slope. This aggregate demand curve has a negative slope, but they both shift up in a parallel reason for the same exact reason. Increased government spending increases aggregate demand in the short run because prices in the short run are flat. In other words, the aggregate supply curve in the short run is elastic. So if aggregate supply in the short run, in the short run, is elastic, and the price level is $8,000, it'll be $8,000 after the shift. So we replace the price level with 8. We solve for real GDP, and we get 10.5. Now that should make some of you go, that looks familiar. Well, it's the same exact real GDP number that we got in the aggregate planned expenditure model when we increased government spending from 3.5 to 4, if you remember, right? Real GDP increased by $1 trillion when we did a $500 billion increase in government spending. Remember, the multiplier was 2, right? Every $1 increase in government spending led to a $2 increase in GDP. But again, remember, like we said back then, increasing G raises the $500 billion budget deficit to $1 trillion. So this is costly. And if government finances this with, well, they're going to finance this by auctioning bonds, who's going to pay those off? Well, future workers are going to pay those off. So future workers will have to support our current deficit with probably higher taxes. So let's see what happens if taxes are lowered to $2.5 trillion. So government, typically Republicans, are going to lower taxes from $3 trillion to $2.5 trillion. Okay, so we replace the 3 with the 2.5, and just like before, like when we did it with the aggregate expenditure model, the demand curve shifts up, just like the aggregate expenditure model shifted up when we cut taxes. The tax cut increases aggregate demand, and again, if we assume that we're in the short run, and this is the immediate effect of government enacting a tax cut, then the price level is not going to change all that much because prices are sticking in the short run typically. So replace the price level with $8,000, and we solve for real GDP, and sure enough, we get a number that looks familiar. When we did this with aggregate expenditure, we got 10.25 trillion too, right? And real GDP increased by not as much as real GDP increased when we increased government spending. That's because we have this marginal propensity to consume in front of taxes net of transfers. So this got a cost. Cutting T raises the $500 billion budget deficit to $1 trillion. Okay, so to summarize, aggregate demand increase if wealth goes up, if expected future income goes up, if variables with a negative sign fall, like the real rate of interest, like taxes. Aggregate demand will increase if investment increases, government spending increases, and exports increase. Aggregate demand decreases if wealth falls, future expected income falls, or variables that enter the equation with a negative sign or with subtraction. If those increase, then aggregate demand falls. If taxes are increased, aggregate demand falls. If investment falls, government spending falls, exports fall. The Congress and President are in charge of fiscal policy. Expansionary fiscal policy, or stimulus, involves a cut in taxes net of transfers or an increase in government spending. Restrictive fiscal policy involves raising taxes net of transfers and or cutting government spending. The Federal Reserve, our central bank, is in charge of monetary policy. Expansionary monetary policy involves lowering the federal funds interest rate, which would increase R and lower I. Well, at least that's what the Fed is hoping. They're hoping that lowering the federal funds rate lowers the rate of interest too. A restrictive monetary policy involves raising the federal funds rate, and the Fed hopes to do what here? The Fed hopes that the real rate of interest increases, which would lower investment. Now that seems kind of weird, right? That the Fed would want to raise interest rates and lower investment? Well, that's what the Fed typically does when we're in an inflationary gap. They want to de-stimulate aggregate demand because maybe fiscal policy has overstimulated aggregate demand. Now I have a simulation, Excel simulation, that you can download and plug all the numbers that we used in this lecture handout. You can plug them into this simulation, and then you can change each variable one at a time to see how aggregate demand shifts. Okay, potential GDP is determined by the quantities of labor employed, capital, human capital, and the state of technology, land and natural resources, entrepreneurial talent, and at full employment. Remember, when real GDP equals full employment output, that's what happens when we're at full employment. Real GDP equals full employment output. The growth rate is probably around 3 or 4, hopefully, if we're nice and stable. Inflation rate, hopefully, is right around 2% if everything's stable. Cyclical unemployment is 0, and the unemployment rate is 5%. The real wage rate makes the quantity of labor demanded equal to the quantity of labor supplied. Along the potential GDP line, when the price level changes, the nominal wage rate changes to keep the real wage rate at full employment levels. Since unemployment equals the natural rate at full employment, there is no pressure on inflation to change. There's no tendency for it to change. We expect it to remain constant. So if it's 2% this year, it'll be 2% next year. Over the business cycle, the quantity of labor employed fluctuates around its full employment level. Hence, real GDP fluctuates around potential GDP or full employment output level. Okay, so let's get a better understanding what full employment output is. Suppose the economy's production function here shows the volume of output that can be produced by its labor force of size L. Now this is the size of labor force, not necessarily the number of laborers working. So L here has two meanings. When we're talking about L being laborers or number of people employed, that generates real GDP. But when we're talking about the labor force, that determines full employment output. And then K, R, and Z are capital, resources, and knowledge and talent. Suppose there are a total of 144 million workers in the economy. This is our labor force. It's much different than the number of people employed. And then resources, capital, and technology are at 400, 100, and 1. Well, Z, K, and R represent long-run variables. They don't change in the short run. They're given in the short run. You have so much in the short run. Knowledge is fixed. Capital is fixed. Resources are fixed. Over the long run, in the long run, you can discover new resources, or you can deplete resources. In the long run, you can enhance your economy's capital, and people within the economy can learn more. But in the short run, those three things are fixed. Now, the number of laborers is not fixed. The number of laborers is a short-run variable. And then the labor force, you can kind of think of as a short-run variable or a long-run variable. It's probably got some short-run components to it, a short-run component to it, and it's probably got a long-run component to it. We'll just think of it as a long-run variable. And over the long run, families can, if families' birth rate, if families have more and more kids over time, the labor force will expand. If the government adopts a policy that encourages people to come to America, then the labor force will expand. And typically those things take time. So we'll just assume that the labor force is a long-run variable, but the number of laborers in an economy is short-run. Like, for example, if McDonald's is swamped and needs people to come in, or needs to increase output in the short run for a busy lunch hour, it can't build an extra drive-through window. It can't add counter space. It can't add grill space. But what it can do is it can call people in that were off during the lunch hour and bring them in to help with the lunch hour rush. So The number of laborers in economy is a short-run variable. Firms can adjust it in the short run. Okay, so we plug the numbers in and we simplify, and we continue to simplify, and we get a very simple production function. I call this the short-run production function. This up here is the long-run production function because the variables that are long-run are free. Down here, this is the short-run production function because we're in the short run, which means Z, K, and R are no longer free. They're given in the short run. Okay, so anywhere on this production function, we're holding technology constant at 1%, K constant at 100 million units, and R constant at 400 million units. And the only thing we're allowed to change is the number of laborers in the economy during the short run. Okay, so we're going to graph the economy short-run production function, and then we're going to compute the size of full employment output. Okay, so we're going to plug in 0 laborers, and when we do that, we get 0 output, which makes sense, right? If no workers are working, the economy's not going to produce anything. And we plot that point. And then we're going to plug in 50 workers, and if 50 workers are working, then GDP will be about $7 trillion. So this L is the number of laborers that are working full-time, 40 hours a week, 50 weeks a year. Okay, so as we add more and more full-time workers, real GDP is increasing. And then we add 50 more workers. So now we have 100 million workers working full-time for the economy. And when that happens, we can build $10 trillion worth of real GDP. And with 150 million laborers working full-time, the economy, with its fixed level of technology, its fixed level of resources, and its fixed level of capital in the short run, will produce $12.25 trillion in real GDP. Okay? So this is the economy short-run production function. Now if we plug into our short-run production function the size of the labor force, which is again different than the number of laborers, if we plug that into the production function, we get full employment output equal to $12 trillion. We have 144 million people, that was given in the problem, that are in the labor force. Some of them are working, some of them are not. You're in the labor force if you are looking for work and you're unemployed. You're in the labor force if you're working. If you stop looking for work, you're no longer in the labor force. So the number of people that are laborers or number of people that are employed is much different than the labor force, or it's slightly different. Okay, so full employment output is $12 trillion. Now, if real GDP is, if 144 million people are working full time, then we're going to be on the production possibility frontier. And the economy will produce $12 trillion worth of output. So this point would be on the production possibility frontier. That point would be on the production possibility frontier there. Now compute the output of an economy if only 120 million of the 144 million workers in the labor force are working. So we plug in 121 million laborers working 40 hours a week, 50 weeks a year, and GDP is only $11 trillion. So this is the situation we find ourselves in right now. The red point is in the production, inside the production possibility frontier. The blue point is on the production possibility frontier. 23 million workers are cyclically unemployed. Remember, we have this natural unemployment, and government's not concerned with 5% unemployment. Government's concerned with unemployment that exceeds 5%. So these 23 million workers would be cyclically unemployed. Well, we'll have natural unemployment, which is structural unemployment and frictional unemployment. Now, compute the output of the economy if 144 million workers in labor force are full-time, 40 hours per week, and 50 million of them are working an extra 20 hours per week. So since 50 million are working an extra 20 hours per week, the effective size of the labor force, the effective number of full-time workers is what? Well, 144 million people are working 40 hours or more. 50 million of them are doing the work of an extra half person. So the 50 million workers are kind of like doing the jobs of 1.5 people. And that's why they're added here. The 50 million people are included here and here. So how many people are working 40 hours a week? Well, 50 minus 144 is 94. So 94 million people are working 40 hours a week for 50 weeks a year, while 50 million workers are working 60 hours a week. So they're doing the work of 1.5 employees. So the effective size of the labor force is 169 employees. So this is a point that would be beyond the production possibility frontier. And this is why unemployment is kind of considered too low. Unemployment is not equal to the natural rate any longer because it's less than 5%. Okay, so here real GDP is greater than full employment output, is beyond the production possibility frontier. Okay, so let's ask the question: what happens if maybe a bunch of companies or companies from overseas start building factories in America, or government starts building some much needed bridges in Manhattan, or government builds some nuclear power plants, or makes it easier for nuclear power plants to be built throughout the United States, or maybe allows firms to go ahead and drill for oil that's on our shores. Well, all that machinery that's going to be put in place is capital. All right, so maybe in that situation, capital increases from 100. It was 100, right? It was 100. Now it's 121. So what happens to the production function? The production function, the short-run production function, rotates up and to the left, rotating via the origin. So at every level of labor, the economy is producing more output, except when zero workers or zero people are working. When there are zero workers working, then we have zero output. So the production function shifts or rotates up and to the left. What happened to full employment output? Well, if we still have 144 million workers, remember, ceteris paribus, we're going to hold everything else constant. If we have 144 million in the labor force, full employment output is now $13.2 trillion. So this is what I was talking about back when we were talking about the economics of healthcare. One way to get to a point that is not attainable, a point E that is beyond the production possibility frontier, is to grow the economy, become more efficient. And I think the best way to do that is to set it free. Every industry that is characterized by freedom and very little government intervention is providing great services, great technology, great choice, low prices. I mean, just look at it. Televisions, laptops, cell phones, computers, software, the internet. Wherever there's freedom, there's great innovation, and companies are making profits, and consumers are happy, and people's lives are made better. But in every industry that you look at that is heavily regulated or owned by government, every business that's owned by government or heavily regulated, banking, financial markets, the post office, Amtrak, either those enterprises are losing all kinds of money, or there's incredible moral hazard due to the bailouts of Wall Street and banks, great inefficiency, and I mean, even the public school system. The public school system is government run. The public school system is doing a horrible job of preparing kids for college. I know, I've seen it. I've seen talent drift. When I first got here, students could actually compute a percent change. Students could actually graph a line. And now it seems like most students can't do those easy tasks that I could do in 6th grade back in the 1980s. Increases in an economy's resources and knowledge, talent, had the same effect as an increase in capital. Now we're going to graph the potential GDP you computed in part 3 with aggregate demand below. Remember when the labor force had 144 million people in it, the square root of 144 was 12. So full employment output is $12 trillion. And it doesn't depend on the price level. Let's go back and look at it. Notice you don't see price level here, 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 or here. Potential GDP is not influenced whatsoever by the price level. It's influenced in the short run by the size of the labor force. Over the long run, it's influenced by the size of the labor force, the quantity of resources in an economy, the quantity of capital in the economy, and the level of knowledge in an economy. So price level does not affect potential GDP in the least. That's why it's a vertical line here. Together, aggregate supply and aggregate demand determine the equilibrium of real GDP and the price level. So the next thing we're going to do is we're going to derive the aggregate supply curve, right? We have 2/3 of the aggregate demand aggregate supply model. We have aggregate demand, we have full employment output. Now we're going to derive aggregate supply. And the goal of policymakers is to keep equilibrium GDP close to potential with the economy growing at 3%, inflation at 2%, and the unemployment rate between 5 and 6%.